Microsoft, and K. Shrinath, General Manager Marketing from Rockwell, to give a presentation on operational and manufacturing intelligence. Shrinath is the General Manager Marketing at Rockwell Automation India. In this role, he is responsible for developing markets across products, solutions, and services, business for adoption of Rockwell Automation technologies by customers and partners. Shrinath has over 22 years of experience in industrial automation industry, working with Sanmar, Zycom, GE Fanuc prior to joining Rockwell. I would like to invite him.
Is the mics on? Are you able to hear? Hello. Yeah. Good evening. I'm happy to be in this slot because typically if you're after lunch and if you're the last speaker, you have a huge challenge. But I think one of the things that we're going to do, myself and Basker from Microsoft here, is to actually try and see how much we don't have to repeat certain things that we've been hearing quite right from the morning. I think this whole discussions around manufacturing intelligence or intelligent information analytics has been quite well dealt upon by many speakers. But what I'm going to do is I'm going to bring a perspective from the bottom, because that's what Rockwell Automation is. We are an industrial automation company, so we come from the operations bottom level to the IT level. So I'm not an IT engineer. I'll try my best to do what I can on that space. I think we heard many speakers. Raghu spent a lot of time in explaining the various imperatives which is driving the global manufacturing space, the challenges that we have been undergoing. And one of the new things which added in the recent past, in the last 5 years, is the economy uncertainty. And that's also causing a lot of challenges to businesses, and in turn, whatever is a challenge to business translates eventually to the manufacturing flow for production and manufacturing. So the factory which produces products are under constant pressure to look at avenues to reduce costs, to be more versatile in the way they produce, to actually look at what the consumer demands are and responding to that very actively and proactively to be able to deal with those challenges which are in the business side. With that being there, there's new realities which is happening as well. One of the recent things that we saw is that there has been a lot of earlier isolated manufacturing. That isolated manufacturing is no longer existent today. Today there is a connected manufacturing between suppliers supplying to the main factories. There are customers wanting to know where my orders are, when will I deliver. So there's a connection between the customers, the suppliers, the main plant, and the overall economy dealing with it. So there's huge challenges associated that translates to requirements on the manufacturing flow. Typically, we know manufacturing is one which converts, raw material, time, people, energy into products. And unfortunately, when we make products, we also sometimes land up into waste. Or we probably have some times, sub-products that we can recirculate back into products. But there's one thing that we always produce as a byproduct of this, which we miss out, is data, and that data with information. And this is produced pretty effectively in the manufacturing through various control systems and various systems which exist in manufacturing. The question is, how much of this data gets converted to information to take real-time decisions that will support business or manufacturing to become more productive, or more producing more quality, or reducing cost of manufacturing. So that's where this whole topic becomes relevant as to what can we do to leverage that data which gets produced as well and put that to actionable usage. This is a reality that CEO confesses. 60% of the data that is there it's difficult to capture sometimes, and even if they capture, it's difficult to interpret. And this is something that has been challenged all the time. And there are only systems getting better of late to be able to address this challenge. And there's a lot of time spent in integrating the data. And that's been the reality of manufacturing. That's been the reality in the business side a few years back, which kind of changed over a period of time with the ERP, supply chain, CRMs coming into effect, where a lot of these business data have kind of become a little bit more structured. And there are still some unstructured data here and there. But if you look at a manufacturing flow, if you walk into any production manufacturing flow, even today, there's a lot of books that people log information on. They write information, they translate the information, they write the pressure, the temperature. There are control systems sometimes, but there are many places where you have a manual operations, they have to do that manually as well. There's a lot of change which is happening there, but still a lot of translation of information. For example, if somebody has to know the overall equipment efficiency of a machine, it's a calculated data. And that calculated data will need actually a lot of 2 or 3 informations to come in together to produce it. And typically this is calculated over an Excel sheet, which is kept somewhere else. So the more we have such kind of unstructured data collection or data storages, the challenge increases in terms of bringing it together. And then this is kind of amplified sometimes because we always have this divide between people who are looking for information and the people who are doing their main products in manufacturing who produce information but not available on the other side. So there's a big wall. And I'm very happy because in this ARC forum, I'm seeing it in a, absolutely there is IT service providers, there are automation companies coming together. I think that's a clear indication that we are going to make a difference working together in this space. So the wall is going to break, is my prediction. Sooner or later it's happening, it'll happen even more. So when the information starts flowing from manufacturing to the other side, to the business side, I think there's going to be even more power going to be available. But the manufacturing, when they produce data, they produce in a lot of bulk quantity because when you really look at manufacturing producing data versus business producing data, manufacturing produces data every second, every millisecond. A PLC controller produces information it runs in milliseconds, it doesn't run in seconds. So it produces a tremendous amount of data in very high speed, but then all that data is probably not what is required for the business to take decisions on. Whereas if you look at the information or the business side, you probably produce a report at the end of the shift, end of the day, or beginning of the month you do a planning and probably revise it every week. So that's the frequency difference between the time and the amount of data that you will produce in manufacturing versus in the business side. But all our information, so we need to get this across, we need to break the wall so that it can come over to the other side to take effective information. Now, even in manufacturing, what happens is there are multiple departments. So let's look at, typically in a manufacturing, I take these 3 departments, operator, maintenance, and plant management. These 3 departments has, again, islands of information. And I'll explain this with an example, what I mean by islands of information. Now, when I talk about islands of information, let me also talk later about the power of bringing these islands of information together. So first I want to establish through these slides 2 contexts to information. One is something called real-time information. Now this is important to understand. What is real-time information? And let me take a non-automation, non-business example to start explaining that. We have these railway answering systems. So you essentially call 139 before you go to the railway station. You actually want to receive somebody. You call 139 a few years back. Then you probably get to know, okay, what time is it supposed to come? The train is going to arrive Delhi at so-and-so time. That's all you knew. But now if you call 139, you will actually get an information that the train has crossed Bhopal on so-and-so time. You call a little later, you'll know the train has crossed Agra so-and-so time. Now look at the difference between these 2. The first one only told you what time the train was expected to arrive. The second one tells you where exactly is the train passed. Now, it's not that accurate that it can predict and tell you today what time it will exactly arrive in Delhi. I'm sure, but knowing that it has crossed Panipat, Sonipat, you probably have a better ability to predict that you probably will see this train arriving in Delhi at 7:30 instead of 7 o'clock. Maybe. That's a good amount of information for you to probably plan your rest of activities to be able to go and receive them. So this is real-time information. Now, from a manufacturing perspective, that's the same power that information has when it converts to real-time information. So I hope that context of real-time information is established in this example. The second thing that you need to know is, even in manufacturing, for you to make a simple decision as whether I can produce so much today to be able to ship out of the manufacturing flow, needs that data to come from different sources. For example, the target needs to come from an ERP system. Always. The targets are set at a high-level system, it comes down. The second is you actually have a production schedule. Now, if you have a target and if you're not scheduled for production for the today, you may not end up in making it by the end of the day. So obviously, the production schedule will have to tell you whether it's going to be produced today. The third data that will come is a computerized maintenance management system, which will say, okay, I have the target, I can produce it, it's targeted, it's planned to be produced, but is my machine up and running to produce it? Now, if you don't have that information, you will still not get the output. So the CMMS system would say that, okay, there's no planned production downtime, so it will produce that. The fourth information will actually be the actual production rate, like the railway example I said. What's the current rate of running? So how much is it producing right now? When can I expect that to get over? The fourth is, if you produce everything perfect, then you don't have rejects, but that's not the real ideal situation. Most times you produce and you recognize there are rejects. So you need the same control system to say, okay, it didn't produce this many parts properly with your quality online or inspection systems. And the fifth one is your quality control. You produced, but you didn't produce to the customer's standards and specifications that you can ship. So it's not produced yet. So all these informations come from different sources within a manufacturing flow, and that makes it complicated for you to interpret and understand data. Now, what do you need to do? You need something to put this all together. Now, the other benefit you have in putting these information together is you actually start driving. We talked about collaboration between manufacturing and business. Let me talk about collaboration within a manufacturing flow, which can actually give you real quick returns. Between a control, and these are the various sources of data which is coming from, and then you actually go to the business system to do that. But if you really look at manufacturing intelligence, what it does is it brings together the whole information from different disparate sources with some context to that data in a real-time basis, and then produce that data as reports and analytics for people who require that data so that you can make some active decisions. And then what kind of decisions can you make? In a floor, these are the typical decisions that you look for. And there's always a belief that ERP will sometimes answer this. Yes, ERP can give you a static answer whether it can be produced, it can be scheduled, but it can't give you a real answer whether it can get really produced. That real ability to produce or to commit a production will come from the actual flow based on what really is happening on that flow. So if you really look at the three departments I talked earlier, the operator, the maintenance, and the plant management, the islands that they are, there is power in collaborating among themselves itself. So when a maintenance person sees a breakdown, typically an equipment breakdown, what's his goal? His goal is to go and fix it. So essentially, most likely, he will go and fix it. But that if the same information is available to the maintenance department as to what really stopped that production happen, then there is a lot more information coming to the other departments to function more proactively, more predictively, to figure out what they can do to stop it next time from failing. So that's the power of collaboration. If maintenance department understands this is the predictive behavior of a failure, then they can actually tell the production plant operations that I think we need to take the machine for preventive maintenance today, otherwise your production will not be produced because you can't, the machine is likely to go down if you have a predictive maintenance schedule plan. So there is power of collaboration between these departments in the production floor, and which can be very powerfully impacting your ability, your decisions to actually impact the production outputs. Now, I just quickly wanted to dwell upon what does manufacturing intelligence do. Manufacturing intelligence first focuses on what's required for that individual roles to be effective first. That's the first primary goal. So if a plant operator's goal is to actually make sure the work orders get executed, cycle times are adhered, he should know, he should be empowered with that information to be able to understand how he is performing. For any performance management, people need feedback. People need to know how are they doing against what they're expected to do. The operator needs to know first. Once the operator knows that, then he can be educated to understand what he can do with that information further. So he goes, he drills down, he finds out what's really caused that stoppage. Has it been stopping every time? Should I call the maintenance guy and ask him to attend it because there's been 3 or 5 or 10 stops for the day today? Or do I still go and bypass or probably fix it and get ahead? So those kind of decisions should be empowered at the operator level to start with, so that his ownership, and we talked a little earlier the cultural change management thing, because information is very powerful and sometimes very threatening. So we need to get that buy-in at the most bottommost layer for people to adopt this practice of being able to share that information and not feel insecure about sharing information. And not all information are beautiful. Some informations are ugly. So the operator takes that. Now when it goes to the maintenance side, the maintenance is interested in keeping the uptime of the plant. So the maintenance can have the same information available once it is produced to be able to deep dive and understand, is this a phenomenon that he sees during a particular shift, or is it a particular part in the equipment which is constantly failing? So there's a lot of information that he can derive with the same source of data that he has been able to drill down. Once he does that, he's able to make some decisions around it. So there is empowerment of decisions at the maintenance level. The plant management is typically interested in the overall plant health. So he's interested about the worker, the operator, he's interested about the maintenance, he's overall responsible to make sure that he produces products at the cost that he is supposed to produce. He's more like a management. He has to make sure that everything is working well and he's making profits for the production operations. So his interest would be to look at, okay, how am I doing with respect to the assets? What can I do to improve them? Am I right on my cost targets? Am I rescheduling my production to make sure that these breakdowns don't come in the way of my production and my profits? So that's where the plant management takes into these informations very actively. Now, so depending on the roles, each one of them have to be enabled or empowered to be able to act on that information themselves. And then we go to the next phase, where I'm going to call Basker to explain how can we then expand this to a much higher level of collaboration, business management, and other. Thank you.
Thanks, Shrinath. Is there no feedback now? Yeah, okay. So what Shrinath was talking about essentially is the things which are happening at the shop floor. If we try and extend this context a little further, we are actually talking to the larger organization, and larger organization is not necessarily just one plant floor. It's probably several plants, and it's probably several different types of functions which are not necessarily present in the plant. So we heard quite a bit about the larger context of management reporting, performance management, and the fact that there is a certain amount of preconditioning before the information can be consumed. And this preconditioning becomes that much more pertinent when we are trying to present information to, let's say, a senior management consumption for a person who's responsible for maybe 4, 5, 6 plants and the sales and the sourcing as well. So first step is where we are collecting, observing and detecting. Shrinath spoke at length about it. The next level is where we assemble and contextualize, and then we evaluate and think. This is the analytics layer. Here we are doing either predictive analysis data mining example was given some time back, or we are just brooding over the data, perhaps in a spreadsheet, and trying to figure out what is hidden inside. Once something is found, we actually take action, or we are expected to take action, and usually the action is being taken by someone who's right at the ground level or who's closer to the ground level, and then we create some kind of an analysis or a practice which goes back into organization context, that is this action really something which was necessary? Is it something which is repeatable? Will I be able to fix this problem every time I run into this situation, taking this action? And once that is validated, does it go back to some kind of a best practices repository? Somebody writes an email saying that I have observed this problem, this was the data, I saw this trend forming, I created this observation, and I took this action. Goes back, sits in an email repository somewhere, nobody knows about it when the next time the same problem is observed. So is there a mechanism by which I can make this email discoverable, or for that matter, create a mechanism to bring this knowledge back into the context when that problem recurs? So that's a question that we'll try to answer. We know that within the enterprise application space, we have business intelligence solutions which are quite mature now. And these have been mature for quite some time. People have learned to use them. People have learned to learn from them. However, at the plant floor, we have a totally different approach to solving problems, manufacturing intelligence being one of them. And first level, once we have bridged the information gaps within the plant floor, we need to have this knowledge jump over this Chinese wall and integrate with the enterprise-wide business intelligence which may be existing. And this is what will create the operations intelligence. Conceptually, yes, we understand, but what does it mean really? It means that when I am running an operation across a large organization, I'll have roles which are not necessarily connected to manufacturing, or at least not at the ground level of manufacturing. Am I able to help them with information which actually aligns with the respective roles, KRAs? Is there a production downtime which actually helps my vice president operations take a decision that this particular machine model is no longer useful for my, my business? For future capacity expansion or for brownfield work, I'll use a different model of machinery. Or if some modernization work was done, how effective is that modernization? Does it help me save cost? Does it help me achieve a higher level of productivity in the new environment? Similarly, a supply chain person will say, if my turnaround time for order was 12 days after it was given to manufacturing, can I, with this new formed practice in one of the plants, get that plant to deliver in 10 days? Is this something that I should endorse in a management meeting, that we should go with model X of the machinery across all plants? Similarly, the plant manager needs to make sure that when the new version of that product comes in, all his people are capable of delivering to a standard which is expected by the senior management. And this is an example of a new product. It could be very well an existing product where some changes are introduced which actually create impact across the organization. But the reality is that this is what we have. We have a really complex mess of information. A lot of this is manual. Quite a lot of it exists in spreadsheets, and people are quite comfortable working with those kind of situations. So how does this get simplified? One level is that we'll have these systems which are carrying the source data. The next level is that we try and pull all of this together and populate something which was referred earlier as a data model. In the Rockwell Microsoft world, we have Vantage Point Unified Production Model, which serves as the data model. And on the right-hand side, you see these are our classical enterprise applications, all familiar names. Once I have these contexts put together, the information integration achieved, and this is, a lot of this is real-time information. It could also be historical information. It could be end of shift, end of day, end of week information. But being able to put it all together into a context. So if I am looking at a downtime behavior across 4 plants, am I able to pinpoint it to a particular model of a product that I am making or a particular type of machine that I am using? That's what this unified production model will help us achieve. And then I introduce the visualization layer. Some of this stuff we know already. Tools have been available for some time, many of them from the enterprise business intelligence world. Some of the newer technologies like we have seen recently, which encourage self-service reporting. We have a few of those coming out now. Self-service reporting or the classical OLAP-based analysis. This is mostly looking at historical. Then the other side is that we could actually bring the historical and the real time together into one comprehensive dashboard. And this dashboard could be specific to a user role. What a plant manager sees versus a vice president of R&D who sees, or a supply chain manager who sees the same information, will see completely different views. I'll build this through. Here is an interesting aspect of it. Now I am seeing some information. Now I may want to connect with people who are connected with that information or who are responsible for that area of work. I can actually find out who's in the office right now, who's reachable, and then contact them. I could contact them through an instant message or an email, or I could call them up. That's all the later part of it. But the fact that there's someone available who can immediately action, that's going to encourage collaboration. And within this environment, I could actually search for previous instances as well. So this is something that we've sort of seen evolving over time. Some of the mature companies in the Western Hemisphere have already started using it quite extensively. There are examples, time permitting, we could talk about it, or you could walk across to the Rockwell booth here, and we could get into the details of this. Now, each one of these contextualized situations, we could look at addressing one or the other of these objectives. Now, these are the value scenarios, if you may. You could actually be looking at harmonizing production report, product reporting, decisions across which plant to make a particular product, or how can I meet an aggressive lead time requirement from a supply chain's perspective. Or for that matter, for a quality perspective, I have got a higher tolerance requirement, or rather higher grade of tolerance requirement, tighter tolerance on a particular product. Which plant should I locate that particular product to? Will I be able to achieve it in plant A versus B versus C, and what are the causative factors of that? Those kind of problems can get solved. And okay, so I think this is where we'll conclude, because we are coming together, Rockwell and Microsoft, to provide this kind of contextual output to the business by leveraging our respective strengths. Rockwell coming from the operations side, fairly rich experience, and our own strength on the IT products and on data management side that Microsoft brings on the table. So this is where I'll conclude.
If you have the extra time, we have a 3-minute video to run a case study of a customer. So if you permit us, we'll run. Yep.
This is an example of a customer. Audio is not there.
Audio is.
Who actually innovated with a new business model using data from the ground level. In this case,
to dramatically change
machinery which is
business
used
process
for
and deliver value to their customers.
The last
audio
20.
stuff? Okay.
MG Bryan, a leading manufacturer of heavy equipment for the oil and gas industry, is using transformative technology to dramatically change business process and deliver value to their customers.
The last 25 years, the industry's been very stagnant in the way that it's been continued to look at equipment. They've continued to build that equipment the same way, you know, over and over. And so what we're trying to do is be leaders and market innovators in the business, and we feel like that's what's going to set us apart. The environments that these trucks are being put in are extremely difficult, harsh conditions, 30, 40 below Fahrenheit to 120 degrees Fahrenheit. So you have a $1.1 million piece of equipment, and air filters are $40 a piece, and there's 4 of them, so $160. If they don't change those, they suck